Okay. So let me just, beautiful. Okay, so now you should see my screen. My OBS is working properly, isn't it? Yes, it is. Okay, beautiful. So our first project is the arithmetic formatter. So you have to create a function that receives a list of strings that are arithmetic problems, sorry, and returns the problems arranged vertically and side by side. Okay, so this is the simplest project out of all of them. So all the specifications are in the readme.md file, so it's a markdown file. Okay, so let's solve it. My code is probably really small right now, and it's probably really blurry on OBS, so let me just make it bigger. And now you should see the changes take place on OBS. Yes, you can see all the changes. Okay, beautiful. I hope it looks a little bit clearer now. If it does, good. So let me close the files tab, make the output a little bit smaller. Okay, now we have lots of space to work on our code. Beautiful. Okay, so let me just switch tabs real quick. Okay, nice. Okay, so now, first thing you want to do is create the function, which they've given you the template right here. So let's start coding. So let's save the operators in a list. Let's save the longest operands in a list. And let's save the differences of lengths in a list. Okay, that's our first step. Okay, so what we want to do is we're taking the operators, all the operators we have, and we're saving them in a list. And this will be useful especially when we turn on solutions, and then they can see the solutions, and for that we need to save the operators. And it's always better to save as many variables as you can, and not too many because that's going to use too much RAM, but you want to save as many variables as you can so that in case something in your code goes awry, or in case your code requires something that you forgot to save earlier, you can save it and you're prepared. So then we're also saving the longest operands. And the reason for that is the longest operands will have the longest equal the little line. You know what I'm talking about? Like say you have 2 plus 3, so just 2 plus 34. So 2 plus 34 and then the line. Okay. So we're saving that just because we want to know how long we want the line to be. And then we're saving the differences in lengths between the smallest operand and the largest operands. And this is useful because we want the operator to be 1 away from the length differences, if that makes any sense. Next, we want to know the number of spaces from the top and the number of spaces on the bottom. Okay, so that we're saving that in a list. So then now we're having line 1, line 2, and line 3. Beautiful. Okay, so now we're checking, after all that, if the length of the problem's input here, which is the list, so if the length, sorry, if you guys are wondering why I'm doing it in this procedure, it's because I have my old code here and I'm looking off of that because I'm not going to sit and rewrite all my code again because that's going to take a really long time. So I'm looking at that code and I'm explaining it to you guys. So if the length of the problems list is greater than 5, which is one of the specifications they've asked for, you need to return error, too many problems. Okay, that's the most basic error you need to focus on, which is very good. So now the one error is out of the way, one error handling thing. Let's work on the next syntax. So now we want to split up the string equation into multiple parts so that we can work with it. So we just want to iterate through problems right now. Okay, so now we're checking if the plus operator is in problem. That's our little variable over here. Then we take that element of the list and then split it by this operator. And then we append that operator to the operators list. So far so good. Okay. Then next we have to check if the minus sign is in that element. If it is, then we do the same as what we did. For the other one, except we change all the variables to minus. Okay? Next, if it is in one of those two operators, which is one of the specifications, we need to return error operator must be plus or minus. Beautiful. Whoops. There you go. So that's the operators sorted out, which is pretty satisfying if you ask me. Because you know one major section of your code is finished. By the way, you guys shouldn't be copying this code word for word, because that doesn't adhere to FCC's academic honesty policy. So you guys should write this code by yourself based on what I'm saying. Don't just copy what I'm doing, because that's not teaching you anything, nor is it adhering to FCC's policy. So you're gonna have your certification revoked, which you probably don't want. Okay, anyway, so now we are now checking whether all the numbers after we split the problems are digits. So let's iterate through problems. And now don't forget, this is now a two-dimensional list. So the problem with that is that there's a list within a list. So there's each element is its own list, because we split the problem into multiple lists. Okay? Sorry, multiple elements. So now we need to iterate through each and every of those mini list, like the list within the list. We have to iterate through those just to check whether the numbers are digits. So let's iterate through that. So the way you iterate through a two-dimensional list is by adding the element of the one dimension, the first dimension, and then adding the element name of the second dimension. Because there's only two numbers in each of these, that means we don't need to be worried about a 0, 1, 2, 3, 4, 5, or iterating through the smaller lists. All we need to worry about is 0 or 1. So now we're checking if it's a digit. So then if it's not a digit, return error. Whoops. Error whoops. Numbers must only contain digits. And then we had an else if problem 1 dot is digit equals to false. Then we do the same thing again. Okay, so that's for another error, which is another satisfying thing. I'm just wondering, one second. This is tabbed properly, is it not? So if I minus this, yes, it's tabbed properly. So then this is one extra tab. So let's remove that because I don't want any indentation errors in my code. Next thing we need to do is check whether each problem, sorry, each number is more than 4 digits, because if it is, then that's one of the specifications. You cannot have that, so we need to return another error. So let's iterate through problems again. I'm gonna have to be doing that a lot. The reason why I'm not iterating through everything and changing everything at once is because blocking code looks a little bit neater, and it also like each section, each error handling is separate from the other ones, if that makes any sense. So we are now checking whether the length of those elements, so 0 or 1, because those are the indexes, is greater than 4. Whoops, I did not mean to insert an emoji. If it is, then I want you to return error numbers cannot be more than 4 digits. And then we do an else if, same thing except with the 1. Oh, whoops, forgot to copy the bracket there. The 1, we have to return the same thing. So far, so good. Next thing we want to do is take the longest operands and length differences. This will prepare us for the coming steps where we actually have to print the formatting. So we want to iterate through problems again. So then we want to check if the length of the first number is less than the length of the second number. Then we add 1 to longest operands, meaning that means that the first number is smaller than the second number. If it's not, then we add -1. That's just the way, that's just like a placeholder to tell the code, okay, either 1 or -1. If it's 1, then add this many spaces. If it's -1, then subtract this many spaces, if you understand. So that's just a placeholder, and it's like a Boolean value, except our own artificially created Boolean value. I shouldn't say Boolean because Boolean is 0 or 1. I would say a digital. Because digital means 2 values. So then we check if the first number is smaller than the second number, then we append 1 to the longest operands list. And this is a little bit confusing, so I have to walk you through this equation. So what we're doing is we're asking for length differences between both of them. So this is the formula you want to use. So you want to add 1 to the problem 1. We just see which bracket I'm on right now. Okay, beautiful. So then we take that. Okay, yeah, I did something wrong. 1 second. Let me just sort this massive mess out. Goodness. Okay. So we take the length of this. Okay, yeah, this is very confusing. The brackets and stuff. Okay. Then we subtract. Okay, so that's, yeah, this is correct. Okay, whew. That brackets mess was insane. But yeah, the whole idea is that you're taking 1, adding it to the length difference, because that's the extra space that must be there. So then when we have to print it, we know exactly how many spaces we need. So then else, because I don't want to type out that entire code again, longest underscore operands dot append -1, and the same thing, except we're subtracting this massive equation from -1. So whoops, -1 minus this. Okay, So that's going to tell us exactly how many spaces we need. Now we're done with all the prep work, we can actually start printing, which is the hardest part. I know, this is only the most basic problem. There are much more to come. So let's keep pushing on. 1 second. Let me just make sure my OBS is still running. Okay, let's go back. Okay, so for lengths so now we're iterating through all the lengths. So we're using the built-in function len to iterate through the length diffs list, which we just utilized over here. 1 second. Beautiful. Okay, so let's just add that little barrier here, because that signifies a border between two sections of code, which is really important when you're organizing. If you guys don't want to follow the organization stuff, by all means, you don't need to, but it's better if you do, because of course organization will help you when you're looking back at your code in the future. And I always wished I had resources to organize, and I knew all this stuff when I started. And because it really gives you, like, when you come back the next day to work on the same project, it gives you a sense of hope that you can finish it. But if everything's chaotic, I just feel a little bit more demotivated. So now, oh jeez, paper. Okay, so then so now we're checking if the length differences, and we're iterating through that, is greater than 0. So if the element we've iterated through is greater than 0, meaning that the value is greater than 0, then I will explain this. In a second. I will explain this. Okay, so what we're doing here is we're iterating through that element itself. So we're iterating how many times the element. For example, if it's 1, then we iterate it through once. But if the element is 2, then we're iterating it through twice. So we're iterating through a 2-dimensional list, basically. This is a 1-dimensional list, but we're iterating through the string itself, or whatever that element is. So then, for that many times, we are adding a string to the print list. So the reason why I use a print list, not just printing it out like that, is because I want my entire output saved. And that way, if anything goes wrong, I can just change something in the output within the list. And I can print different values of the list as it goes along the code. That's debugging. So then after this, we print another space. By the way, if you guys haven't seen the requirements, this stuff would seem a little bit weird to you. So hopefully seeing the requirements helps you understand this better, because this is a heavy problem to take in. I struggled with this initially, even though it is the easier one out of all of them. Okay, so then what we're doing is then we're appending that value, that space, to the end. Beautiful. So then we're doing the same except for the opposite. How many spaces? This is 4, right? Let's check. 1, 2, 3, 4. Beautiful, yes. And it needs to be 4 spaces. That's another thing on the requirement. 1, 2, 3, 4. Beautiful. Okay. So then, if we're doing that if statement, now we need to do the else. So then we're appending a space to this print list. I think it's actually 2 spaces. Yeah. Wait. 1, 2. Yeah, it's 2 spaces. It has to be 2 spaces. That's one of the requirements between each problem, I think. Yeah, between each problem. So then we're doing the same thing. We're appending the problem. This is actually not too long a code, by the way. Like, it's relatively shorter. The other ones are much shorter than this, but it requires a lot more brain work. This is a lot of as you go on, you come up with the logic, and it's not that hard logic to come up with. So 1, 2, 3, 4. Beautiful. So now we've added all the spaces and that nonsense here. So then the next step, we want to iterate through the length differences again. I know this is a lot to take in. If you guys have anything, feel free to reach out to me. Not in the comment section because that's disabled, but if you want to follow me on Twitter and DM me that way, you can send me an email using my business inquiries email. You can do that. That would be greatly appreciated to see that you're taking the initiative to understand it, but not to copy it. Then, so now we're iterating through the length differences list, and then we're adding the operator because all of these lists are the same length. So we're just taking the operators of this. So the index of the length differences, we're doing that for the operators instead because all of them are the same length. Oh Jesus, this is very tedious to type in like one go. Yeah, there's a lot left. There is a lot left. Okay, so now we're doing the spaces for the second line. So this is for the second operator. So now we're taking the absolute value because some of them are -1, right? Okay, that's done. We're adding the space. Then next thing we need to do is add the actual operand. Beautiful. This is turning out to be good because the operator is here, right? The operator, like the plus or the minus. Then we need to add the actual operand, so the number, if that makes sense. Yeah, you need some math skills for this, I'm sorry. Because you need to know what operators, operands, and stuff like that mean. Let me just encapsulate this in a bracket. So what I'm doing here is I'm checking. You cannot have extra white space at the end of the line, so I'm making sure there's no extra white space here. Oh, whoopsie. Oh, I messed it. 1, 2, 3, 4. Beautiful. You just need to make sure you get that right. Otherwise, the entire formatting will be messed up, and you don't want that. So now we're having an else for this if conditional up here. We're almost done the spaces. We're close. The next step is like the dashes to the line. Oh, whoopsie. Whoops. Okay, there you go. Boom. That's done. Then we need to append the other spaces to it and the problems. So let's go do that real quick. Then we need to check if for no extra white space, that means if it's at the end. Then if it's not at the end, then continue adding the space. Because extra white space, the tests won't pass. And I struggled with that for a while. I was on the forums asking for help. And then I got the answer from someone saying there was extra white space. So thank you for that. Okay, next, we're done. We're done with the spaces. Whew! That was probably the hardest part of this, which is pretty crazy. So I am proud of you if you've held on for this long. Okay. So the next step is to iterate through all the longest operands. That way we can print the solution. This is for the dashes first, but then the solution will be based off of this too. Okay, so we're getting there. We're almost done. So longest underscore operand. So we're iterating through the longest operands list. So this is why prep work is really important. You want to capture as much user input and use a lot. Make that very useful for your code, because this is heavily reliant on user input. So now we're checking if that was -1 or 1. So what we're doing right now is we're taking, if it was -1, then we're taking the length of operand 0, so because that one would be longer, and if it was 1, then the bottom one would be longer, so we take the length of that one, and that's how many dashes will be there, if that makes any sense. It's a little bit confusing, the logic. Oh, whoops. I don't mean to do that. Yeah, that's a little bit of a complex equation right there. Oh, and we need 2 extra dashes because of the space and the operator. Then, so this is the dash. Don't confuse that with the minus. That was something you should not do. Number underscore of dashes. Let me actually copy this syntax and change that to 1. This index. Beautiful. Then append a dash for that many times. Beautiful. Dashes are done. Almost done, actually. We just need to do one more space. And again, we have to do the white space check. So there's a lot of if statements. This is the most simple way you can do it. I'm sure someone will come up with like this whack or library, crazy way of doing things, like some oop way. But this is the most simple way to do it without having any libraries or anything. Yeah, no libraries. Look at that. Glorious. The only function we make use of that's like not normally used, I mean like mathematically helping, is AVS, absolute value. That takes the distance of a number from 0, if that makes sense. So -1 is the distance from -1 and 0 is 1, so the absolute value is 1. -279, the absolute value is 279 because -279 is 279 away from 0. So then let's 1, 2, 3, 4. Beautiful. And that was the white space check up here. Okay, so then now this is the return statement. So now we're gonna make use of the print lists. So the dot join method, what it does is it joins the list to make it one string, all the elements of a list. It's a really cool method, and this is whatever you want things to be split by. So for example, when you join it, if I put an X here, everything will be joined, like each element will have an X beside it when it's concatenating. And then /n, which is the new line character, create a new line. And then again, join print list 2. So this is where it all comes together, boys. Where it all comes together. And the dot join print underscore list underscore 3. Okay, we have the return statement done. So instead of returning arrange problems here, we just return underscore statement. Okay, that's that for the most part. And then 1 second, let me come back to my thing. Okay, so beautiful. We're close. This is relatively short code, so you don't need to worry about having a long time to type this. I'm doing it all in one go, so if you're doing it over a course of a week, that's the best way to do it. I didn't have that time on my hands when I did it, so now we're creating the fourth line here. So we're instead of unnecessarily creating it here and wasting RAM space, what we're doing is we're just creating it if the display parameter, which is one of the parameters you can have, is set to be true. I forgot to set that parameter as one of the things. It's a default one. So if you don't specify it, it has to set to false, so it doesn't display. Beautiful. So then here, let's go back. So if display equals to true, so then we set the solutions as a list and print list 4. So now we iterate through problems again. I'm sorry, we're iterating through problems way too many times, but it's okay. This code runs extremely fast. I'll show you here. Okay, so then if operators problem is equal to plus, so then now we're referencing the operators, so then we add them together. This is the best part, because you get to do this in actual math. So now we're converting that to an integer. So then we're converting this to an integer too. This is the boring part, but the fun part is actually doing the math. The boring part is iterating through it every damn time. Okay, we have a bit to go. That's all. We're good. Okay, so then okay, beautiful. So now, yes, again, we'll iterate. I should make a hotkey for iterating through problems, because I type it so much. So then we're checking. Did I do that right? Oh, whoops. I did not do that right. So watch out for that. There you go. So we're checking if the length of that is greater. So now we have to justify it. But there's a built-in function for that. But unfortunately, I did not use the built-in function. I wanted to do this myself. So I basically spent an hour and a half figuring out the logic to recreate the right justification of built-in function. It's called rjust if you want to check it out. Okay. I mean, the less you use built-in functions, there's nothing wrong with it. You get to learn the logic much better, and you learn a lot more. So now we're in the number of spaces, converting them to a string, and then checking how many spaces we want. Okay, beautiful. So then else, then we problems. Yeah, the brackets confuse me a lot. I just need to take my time to see exactly where I'm at. Okay, and problem. Beautiful. There you go. So we're done the spaces part. We're almost done. We're so close. We're really close, actually. I'm seeing my other code on the screen. And then it's looking like we're really close. So now we're iterating through the spaces in that num spaces list. Yeah. I'm gonna have to divide this up into parts, because this is gonna be one massively long video. So then beautiful. Then so we're adding a space, and then so now because we're iterating through whoops, the spaces, we're adding the solutions of that element. So whatever that the spacest element of solution, if that makes sense. So spaces. So let's now check. So now we're doing the white space check again. The white. That should be a painted in term for this FCC problem. The white space check. So then beautiful. So now finally we've got to iterate through print list 4 and start adding all these values into that. So let's do this, boys. You guys should get the gist of what I'm doing now. I'm iterating through print list 4. Then I'm checking if this is an integer. Then oh whoops, I did not want to do that. Print underscore list underscore 4. Oh, why did I type str? That was my fault. And then so now what we're doing is we're checking if it's an instance of int, and if it is, then we're making it a string. Then so that way we can concatenate, because you can't concatenate integers, unfortunately. Beautiful. Oh my god, I think I messed up the indentation here. Did I? Oh no, I didn't. I know I'm still within this. So now we're this massive nonsense again I explained earlier. So then we're doing a new line arguments, and then we're keep concatenating each and every list, and now we also have to add print list 4 right now. So then plus slash n backslash n, and then we gotta do there you go. So now we wanna return statement. Beautiful. Last thing we need to do is add the else to that solutions if statement up there. This one. And now we are done. Finally, I thank you guys for sitting through that. So now all we gotta do is I think we need to make some modifications to main.py. Or not actually. Yeah, we don't need to make any modifications. So now let's run the code and pray to God that it works. Okay. Oh, what did I do wrong here? Line 2. Oh, that's unfortunate. Wait, this isn't main.py. Oh no, this is arithmetic arranger. For line 48. Line 48, where are you? What did I do wrong here? Did I do something wrong? 4 lines in range. That's interesting. What did I do wrong here? Let me compare it to my other code. Let's see what I did wrong. Line 48 for lens and range then diff. So yeah, right under here. Did I miss a bracket? I have no clue what I did wrong, so I'm just gonna take my other code and just replace it, and then it should work. Let's see. Okay, so then I'll just yeah, all this code is available on GitHub, by the way. It's in the description. All links are in the description, so don't worry about that. So let's run. There you go. So there was just something wrong there on some unforeseen problem. So it does it really quick, 0.001 seconds, and it prints it properly. As you can see, it runs all the tests properly. So that's the first challenge. So let's move on to part 2 now.